Hello my students, this is P. Venkateshwarlu, PGT Physics. In last video, we have to discuss with fluid statics. Means the properties of fluid which are at rest, Pascal's law, density, these are the things we have to discuss in previous session. In this case, we need to discuss about hydrodynamics. Hydrodynamics, which is defined as the properties of fluids, which are in motion. Okay, so hydrostatics is the sub-branch of physics which is in mechanical properties of fluid, which deals with properties of fluid, the fluids which are in motion. Okay, which are in motion. Okay, here after that we need to discuss about types of fluid flow. Types of fluid flows means, so we know that fluid means what, my dear children? The substance which can flow. The substance which can flow. Yes. Okay. So what are the substances can flow? Yes. Yes. Liquids, gases can flow. So in this case, we can observe many fluids which are in motion. So we can observe in a pipe, okay, in a water pipe how the flow, in a canal how the flow. So in rivers, so how the water can flow. Okay, so that we need to discuss about in this session. Okay, so types of fluid flow. Okay, so types of fluid flow. Here, the types of fluids majorly classified into three types. So what are they means? First one, streamline flow. Streamline flow. Second one, laminar flow. Third one, turbulent flow. Okay, see here, we know that hydrodynamics is the branch of sub-branch of physics which is in mechanical properties of fluid, which deals with the fluids, the properties of fluid which are in motion. Okay, here types of fluid flow. What are they? How many types? Majorly classified in three types: streamline flow, and laminar flow, and turbulent flow. Okay, my dear children. So one by one we can discuss with now. Coming to streamline flow. Streamline flow See, in a streamline motion, each particles in the streamline flow, the fluid passing through the point that travels along the same path, and the velocity of the particle as same as the preceding path, which are in a single path. Okay, my children, understand? See here. So consider a pipe. So this is pipe. Okay. In that we have to take one streamline. Okay. So this we can say streamlines. Okay, in this case case, consider the particles, liquid particles. Okay, understand, in this case, each particle passing through same point. Each and every particle passing through same points. Okay, so the particle having same velocity as the preceding value. So we have to take one streamline. Okay, like this. Consider P and Q. So the particle velocity P is same at all points. Okay, here P and Q are the particles. So Q is passing through some point, then P also passing through the same point. Okay, so and particle execute same direction at every point. Okay, so the particle velocity as the preceding value of the same path. Okay, see here having some properties. Okay, what are they means? Here there is no cross, no streamlines, no two streamlines are cross each other. Okay, so these are the streamlines. Okay, these streamlines never intersect. Understand? So consider a pipe. In the pipe, fluid can flow. So in the form of streamlines. So by observing, we can't see these streamlines. So in this streamline flow, every particle in a streamline passing with the same velocity at every point. The velocity of the particle is same as the preceding particle. Okay, understand my children? So consider one streamline. Okay, so here P and Q. So at the all points which gives the fluid direction is same. The velocity of the fluid is same. Okay, at every point. Understand my children? Okay, so we know that the properties of streamline. Here these are the streamline. These two streamlines are never intersect. So if we can say streamlines are close to each other like this. Okay, understand? So streamlines are close to each other. So crowded means speed is more. Okay, means the streamlines are crowded, the velocity of the fluid is maximum, or the speed of the particle is maximum, my dear children. Understand? Next, laminar flow. Okay, so when fluid passing through horizontal surface, laminar flow, which is defined as if the fluid flow on the horizontal surface in the form of layers, different layers having different velocities, then that flow of fluid is called laminar flow. Okay, see here, when fluid flowing through the surface, which surface is horizontal surface. Okay, so in this case the fluid flow can like a layer by layer. Okay, so understand, so the fluid can pass like layers, one by one, another layers. Here these layers having different velocities. Okay, so one layer do not enter into the another layer, through layer by layer. Here in this case, one layer of the fluid will not enter into the another layer. Okay, understand my children? So this we can say laminar flow. Okay, see here we can consider laminar flow in the form of tube. Okay, see here. These are the layers. Understand? So these are the layers. So one by one layers. Okay, when the fluid is passing through horizontal surface, the fluid can form layers. Okay, so here each layer will not enter into the another layer. Okay, so understand this type of flow is called laminar flow. Laminar flow. So laminar flow is a streamline flow. Laminar flow is a streamline flow. Okay, understand my children? Okay, next turbulent flow. Turbulent flow. Third one. Okay, so coming to turbulent flow in rivers and canals. So turbulent flow. See, in rivers and canals, where the speed of water is quite high or at the boundaries surface caused the abrupt changes in velocity of the fluid because of irregular such flow of liquid called turbulent flow. Okay, my children. So what, my children? See, in rivers and canals where the speed of water is quite high or the boundary surfaces caused the abrupt changes in velocity of the flow because of irregular such flow of liquid is called turbulent flow. So consider a canal, or suppose the water can passing through a canal. Some stone is there, stones like this water can flows in a canal. Okay, so at the disturbance at the boundary, water can flow like this, brilliant nature like this. Okay, understand, my children? So water, the speed of the water is differ when the fluid passing through boundary surfaces. Means in canals and so rivers, we can observe the water flowing on the stones. Okay, or disturbances. In this case, water can having different velocities. Okay, so here we can see that the nature of the speed of the water is whirling. Okay, so means rotating like that. Okay, this type of fluid is called turbulent flow. Turbulent flow. This type of flow is called turbulent flow, my children. Next one, we need to discuss about equation of continuity. Equation of continuity. Equation of continuity. Okay, equation of continuity, my children. Okay, see, what is the statement of this equation of continuity? During the streamline flow of the non-viscous and incompressible fluid through a pipe of varying cross section, the product of area of cross section and the normal velocity remains constant throughout the flow. Okay, my children. So once again, what is the statement? During the streamline flow of the fluid, non-viscous and incompressible fluid through a pipe of varying cross-section area, the product of area of cross-section and normal fluid velocity remains constant throughout the fluid which can flow. Understand, my children? Here, so what indirectly area into velocity is constant. Area into velocity is constant. Okay, so area into V is equal to constant. Understand? So means here area into velocity is equal to constant. Okay, here, so we can say one pipe having different area of cross section. Different area of cross section. So why a streamline flow can move inside this type of pipe? Okay, the product of area and velocity is constant. Here we can by saying definition we need to use that words non-viscous. Okay, understand non-viscous. 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 Okay, non-viscous means no friction between the layers of fluid. Okay, understand? Non-viscous means we know that the fluid can flow. So, which is said to be laminar means fluid layer can flow another fluid layer. Okay, in this case, some friction is developed between the layer. Okay, so that friction we can say viscous force or viscous. Here we can take the fluid, non-viscous fluid. Next, we can term that is incompressible. Some of the fluid on the application of external force, okay, the volume of the fluid will decreases. Okay, understand? Here we can say incompressible means there is no change in the volume of the fluid after the application of force. Okay, understand? That we can say incompressible force. Okay, understand? So coming to the this derivation. See here, consider a pipe. Area of cross section is A1. Okay, so velocity is V1. So here the fluid can flow. Okay, in a delta t time. Okay, so the distance covers distance d is equal to delta t into V1. Okay, this is the layer of the fluid. This is the velocity which can move in delta t time, which covers d is equal to distance is equal to delta t into V1. So here area of cross section is E1. Up A, this is position A, and we can consider B. Okay, B. The area of the B is differ. A2, velocity V2 matters. In this case, the fluid can flow in delta t time. The distance is delta t into V2. What manner? The distance covered in unit time is delta t into V2 because velocity is equal to distance by time. Okay, distance it is denoted D. Time you call it delta t. Understand my student? Very important one. So from this we have to get that derivation. So consider a pipe of non-uniform cross section area. Understand? So consider 2 points A and B. Okay. So the same amount of the fluid can passing through different area of cross section. Okay. See here, this is area A1. So at the area V1, the velocity is normally V1. Okay. Understand? Here area is A2, velocity is V2. Okay. So in the same time, in the given time, the fluid can move. Distance. Okay. In a given time, the fluid can move some distance. That distance is equal to velocity into delta time. Okay. So at the given time, at B, the fluid can move in a particular distance, that is D. that is D. Okay, or it is D1 or it is D2. Okay, see here in this case delta T in a given time, delta T into V2, delta T into V2. Understand? See here, you can say at point A, at A. So what is the mass of the fluid? Mass of the fluid from the density. Density is equal to mass per volume. So mass is equal to density into volume. Density into volume. So mass is equal to, what is the density? Density of the fluid flow. What is the volume? Volume is equal to area into distance. Area into distance. Okay. So rho A into D. Okay. So here M1, mass of the fluid can flow at M1. Mass of the fluid can flow at M1 is equal to rho 1 into area 1 into D. D1 is equal to what, man? Delta T into V1. Delta T into V1. Next, M2 at B. Rho 2 A2 delta T into V1, because D2 is equal to delta T into V2. Okay, according to conservation of mass. Conservation of mass. Okay, understand? Conservation of mass means mass neither be created nor be destroyed. Mass can neither be created nor be destroyed. Okay, understand? M1 is equal to M2. M1 is equal to M2. Understand? So then rho 1, A1, density same. Rho is equal to rho 1 is equal to rho 2. Okay. Rho 1, A1, delta T, V1 is equal to rho 2, A2, delta T, V2. Okay, so rho A1 delta T V1 is equal to rho A2 delta T V2. Rho gets cancelled, delta T gets cancelled. You can get A1 V1 is equal to A2 V2. So from this AV is equal to constant. AV is equal to constant multiple. Okay, so understand? So here during the streamline flow of the non-viscous and incompressible fluid through a pipe of varying cross-section area, the product of area of cross-section and the normal velocity of the fluid remains constant throughout the flow is called equation of continuity. Equation of continuity. Okay, my children.